Now let us see these three examples. Design a Mealy machine in order to find the ones complement of a given number. Second problem, design a Mealy machine in order to construct 2's complement of a given number. Third one, design a Mealy machine in order to increment the given binary number by 1. First, let us see the first problem. The first problem is, so design a Mealy machine in order to find ones complement of a given number. We know what is ones complement. Ones complement means zeros are converted into ones and ones are converted to zeros. Let us take an example. Let we have an input string like this, 1001. So ones complement of this number is, so 1 is converted to 0, 0 will be converted to 1, 0 will be converted to 1, 1 will be converted to 0. So 0110 is the output for this input string. So here the input alphabet sigma is equal to 0, 1, whereas the output alphabet also contains two symbols. Input alphabet contains 0 and 1, whereas output alphabet also contains 0 and 1. So now we have to design the Mealy machine. A Mealy machine is nothing but DFA only. So here if the input is 0, then the output is 1, whereas if the input is 1, output is 0. So only one state is enough here. So Q0, only one state is enough here. If the input is 0, it produces 1 as the output, whereas if the input is 1, it produces 0 as the output. So this is the Mealy machine for this problem. This is DFA only. Why? Because DFA means what? Each state must use all the symbols present in the alphabet. Here the alphabet contains two symbols, 0 and 1. So on Q0, 0 is applied as well as 1 is applied. Okay. We know that in DFA we have a final state, whereas in Mealy machine we don't have any final state. Okay. Now let's check whether this diagram is correct or not. So here what is the input here? 1001 is the input here. So let us take the state here, Q0. So Q0. So what is the symbol here? 1. So Q0 on 1. Q0 on 1. It produces Q0 only. But 1 means what is the output? 0 is the output. So here the output is what? 0. Next 1 is applied. Next we have to apply 0. Q0 on 0 means Q0 only. But it produces 0 means what? What is the output? 1. So 1 is the output. So next let us apply this 0. So Q0 on 0 means Q0 only. But 0 means what is the output? 1 is the output. 1 is the output. Now let us apply 1. So Q0 on 1 means Q0 only. So 1 means output is 0. So we got output as 0110. So 0110 is nothing but 1's complement of this number. So with this we can conclude that our Mealy machine is correct only. Now let us find out the second, let us see the second problem. What is the second problem? Second problem is 2's complement of a given number. Third problem is increment binary number by 1. So let us see the second problem. What is the second problem? Design a Mealy machine in order to find 2's complement of a given number. 2's complement is equal to 1's complement plus 1. 1's complement plus 1. Let us see two examples. Let me have an example like this. 0, 0, 100, 100. So we have to find 2's complement for this number. So 2's complement means first we have to find the 1's complement. 1's complement means zeros are converted to 1's, 1's are converted to 0. So 0 will be converted to 1, 1 will be converted to 0, 0 will be converted to 1, 0 will be converted to 1, 1 will be converted to 0, 0 will be converted to 1, 0 will be converted to 1. So this is the 1's complement. Now we have to add 1 to this. So 1 plus 1 means 0 with a carry 1. 1 plus 1 means 0 with a carry 1. 0 plus 1 means 1. Next 1, 1, 0, 1. 1, 0, 1, 1. This is the output. Now let us take another example. Let me have a string like this. 10100. Let us find 2's complement for this binary number. So 10 means 1 is converted to 0. 0 will be converted to 1. 1 will be converted to 0. 0 will be converted to 1. 0 will be converted to 1. So this is the 1's complement. Next we need to find the 2's complement. For that we have to add 1. 1 plus 1 means 0 with a carry 1. 1 plus 1 means 0 with a carry 1. 0 plus 1 means 1. So 1, 0. So here if we observe the logic here, if the input is 0, then the output is 0. If the input is 0, output is 0. If the input is 1, output is 1. So that means here instead of reading the data from MSB to the LSB, here we have to read the data from LSB to the MSB. Here this 0 is called as most significant bit, whereas this 0 is called as least significant bit. Here we have to read the data from least significant bit to the most significant bit. Okay, read the data from least significant bit to the most significant bit. Up to first one, we have to keep the bits as it is. So up to first one. So this is the first one. Why? Because here we are reading the data from least significant bit to the most significant bit. So keep this 0 as it is, keep this 0 as it is, keep this one as it is. So up to 1 we have to keep the bits as it is. But after 1 we have to complement each and every bit. So 0 will be changed to 1. So 0 will be changed to 1. 1 will be changed to 0. So 0 will be changed to 1. So this is the logic here. Here we have to read the data from least significant bit to the least significant bit to the most significant bit. Here 2 points are there. The first point is up to the first one, keep the bits as it is. And the second point is after the first one, complement each and every bit. Let us see whether this is correct or not. So here this is 0. So 0 means 0 only. 0 means 0 only. So 1 means 1 only. So that means here also we are reading the data from least significant bit to the most significant bit. Up to the first one, keep the bits same as it is, and after that complement the bit. So 0 will be complemented. So 1 will be complemented 0. So this is the logic here. Now let us draw the diagram. Okay. So Q0. So here what is the logic? Up to first one we have to keep the bit as it is. So if we apply 1, then the output is 1 only. If we apply 0, then the output is 0 only. Up to first one, keep the bits same. So Q0 and 1 means it will goes to the Q1. So after the first one, what we have to do? Complement each and every bit. So this is nothing but 1's complement. So 0 will be converted to 1, 1 will be converted to 0. So up to first one, the output is same only. So 1 means 1, 0 means 0. If we apply 1, then it will goes to the Q1 state. After first one, what we have to do? We have to complement each and every bit. So 0 will be converted to 1, 1 will be converted to the 0. Now let's check, this is the Mealy Machine for this problem. Now let's check whether our logic is correct or not. So for that purpose, let us take this one, simple example. 1, 0, 1, 0, 0. Here we have to read the data from LSB to the MSB. So let us take the state Q0. Q0 on 0 means Q0 only. So we will be at Q0 state only. What is the output? Q0 on 0 means 0 is the output. So 0 is the output. Next we have to apply Q0 on this 0. So Q0 on 0 means Q0 only. What is the output? 0 is the output. Next apply Q0 on 1. Q0 on 1 means what is the output? What is the output? 1 is the output. We will go to the state Q1. Next apply 0 on Q1. So Q1 on 0 means we will be at Q1 only. Q1 on 0 means Q1 only. So what is the output here? So 0. Q1 on 0 means 1. Q1 on 0 means output is 1. Next we have to apply Q1 on 1. Q1 on 1 means Q1. But what is the output? Q1 on 1 means the output is 0. So here what is the output? 0, 1, 1, 0, 0, 0. So that is the output. Okay. So in this way we can find 2's complement of a given binary number. Now let us see the third example. So what is the third example? increment given binary number by 1. Increment given binary number by 1. So we have to increment given binary number by 1. So let us see an example. 0, 1, 1, 0. Let us see this example. So here we have to increment given binary number by 1. So you add 1 to it. So 0 plus 1 means 1. So instead of that, so what is the previous example? We have taken the previous example as 1, 0, 1, 0. So let us take complement of this number. So let the number is 0, 1, 0, 1, 1. Let the number is 0, 1, 0, 1, 1. Let us add 1 to it. 1 plus 1 means 0 with a carry 1. 1 plus 1 means 0 with a carry 1. 0 plus 1 means 1, 1, 0. So let us see the logic here. Okay. So 1 means 1 is changed to 0. Next 1 is changed to 0. 0 is changed to 1. So here also we have to read the data from least significant bit to the most significant bit. So up to first 0, we have to complement each and every bit. So 1 is converted to 0, 1 is converted to 0, 0 is converted to 1. But after first 0, keep the bits as it is. So 1, 1, 0, 0. Let us see another example. Let the string is like this. 0, 100, 100. Let us add 1 to it. So 1, 0, 1, 0, 0, 1, 0. So here what is the logic? Up to first 0, invert each and every bit. So here this is the first 0. So invert the bit. So 0 will become 1. And after that keep the bits as it is. So 0, 1, 0, 1, 0. So keep all these bits as it is. So now let us draw the Mealy Machine for this diagram. So let the state is Q0. So here what is the logic? Up to first 0, we have to complement each and every bit. Up to first 0. So if 0 is the input, then 1 is the output. Okay. Whereas if 1 is the input, then what we have to do? We have to complement each and every bit. So up to first 0, we have to complement each and every bit. So if we apply 0 on Q0, we will go to the Q1 state. So after first 0, we have to keep the remaining bits as it is. So 0 means 0 only. Next 1 means 1 only. So 1 means 1 only. Now let us see an example in order to check whether our Mealy Machine is correct or not. 0, 1, 0, 1, 1. So here also we have to read from least significant bit to the most significant bit. So first state is Q0. So Q0 on 1 means Q0 only. But the output is what? 0 is the output. Next, apply Q0 on 1. Q0 on 1 means Q0 only. But the output is 0. Next, Q0 on 0 means Q1. But the output is Q0 on 0. What is the output? 1 is the output. Next, Q1 on 1 means Q1. But the output is 1, 1, 1. If the input is 1, output is 1 only. Next, Q1 on 0 means output is 0. State is Q1. So what is the output? 0, 1, 1, 0, 0. 0, 1, 1, 0. So with this we can conclude that our mission is correct only. In this way, we can design Mealy Machine for finding 1's complement of a given number, 2's complement of a given number, as well as we can increment the given binary number by 1.